So let's talk about rotating element bearing selection. First of all, why do we need to know how to select a bearing? Simply put, bearings experience different types of loads within their lifetime, which is normally 9 times 10 to the 7, which is average lifetime. And these loads can include things such as load magnitude, types, which are like axial or radial, are also known as angular or radial loads. Direction of applied loads, which is similar, and also the bearings can experience vibrations. So let's look at the life requirement equations. L is equal to LR times C over FR to the power of 3.33, or for required capacity, we use FR times L over LR to the power of 0.3. And here LR is our corresponding life, which is 9. Next, let's look at our reliability requirements. For this, we have the equations L equals KR times LR times C over FR to the power of 3.33. And our C required in this instance is FR times L over KR times LR to the power of 0.3, where KR is the reliability factor, which is less than 1. Let's look at the influence of axial loads as well. In this graph, L10 is equal to 10% failure bearings, and L10 is the industry standard, basically 90% reliability. So here, anything to the right here is 90% reliability. Here's 80% reliability, and here's 60% reliability. And you can see from this that our life increases as we get lower and lower reliabilities. For determining KR, we use this graph. And here, let's say we have 94% reliability. Our KR at 94%, will be 0.7. When we have radial ball bearings, i.e. 0 degrees, we must determine what FE is. And FE is determined by FT over FR, where FT is the thrust load and FR is the radial load. The following equations show the parameters for FE, which are determined by FT over FR. And we get these formulas from determining what that FT over FR factor is. For angular ball bearings, it's much the same. It's FT over FR once again, which you must determine from the question, and that'll give you your equations for FE. Lastly, let's discuss the case when we replace FE for FR and add KA to these equations. So here we have our FEs, which we determined, and we go here and we have these following equations. Let's try an example question. Here it says select a ball bearing for a machine press fit onto a shaft intended for a 10-hour use per day at 2500 RPM. Radial and thrust loads are 1.35 kilonewtons and 1.78 kilonewtons respectively, with moderate to heavy impact. So first, let's look at the given. We have N, which is equal to 2500 RPM. We have FR, which is equal to 1.35 kilonewtons, FT, which is equal to 1.75 kilonewtons, and we have moderate to heavy impact. So what is our required? Our required is the radial and angular C required, and ball bearing selection, or which ball bearings we should use or are able to use. So some data that we have. Let's assume 90% reliability, as that is industry standard, and therefore we have a KR of 1 and an LR of 9 times 10 to the 7. Here, if you remember, 90% reliability gives us a KR of 1. Yep. And then some other data here. We have moderate to heavy impact. Therefore, our KA is equal to 2.0. If you look here, moderate to heavy, 2.0. And lastly, we have FT over FR, which 1.75. This will give us our FE, if you remember, is 1.3 kilonewtons. Therefore, if we look, we must use the middle equations from both, as is 1.3 kilonewtons. So, let's determine our radial and angular FEs. So we have this formula for our radial FE, determining our radial FE here. and that'll give us an Fe of 3.6 kilonewtons. And for angular, 1.75 times 1 plus 0.870 times 1.3 minus 0.68 gives us Fe of 2.7 kilonewtons. We must also determine the lifetime. So let's take a conservative amount here, which will be 30,000 hours. From this, we can determine our L for our C required equations. So 30,000 hours times 2,500 RPM times 60 minutes per hour. That's to get rid of the minutes and hours here. We are left with 4.5 times 10 to the 9 cycles. Let's continue this question on radial, angular. Now we're going to find our what our required loads will be. So CR we have this equation as previously stated, and when we plug the numbers in, we get 23.3 kilonewtons for radial ball bearings. That's how much we require, and 17.5 for the other. So the way this table works, we're going to find a number for 0 degrees and 25 degrees, and we have to find it so that it's greater than 23.3. So 23.5 is greater. If we take 110 divided by 5, we get 22. L is 22 then. For the next ball bearing type, we take 90 divided by 5, 18. So we get 218. That's the next ball bearing that we may select. And if we want it to withstand 300 kilonewtons or so, we take 70 divided by 5, gives us 14, and we're left with 314. So for our angular ball bearings, 17.5, remember that's our C, so we must find something that's greater than but not less than 17.5. So 20, we have 5, and L will be L18. We have 213 for the next ball bearing selection, and 310, I believe, for the last. And those are all the ball bearings that we are able to use.